just discuss the first three problems of this sentence. So the first one is to find the number of good pairs. So this question is generally of easy level, so you can brute force it, like the constraints are very low. So let's see what the question says. Like you are given two integer arrays, nums1 and nums2 of lengths n and m respectively, and you are also given a constant integer case. A pair I comma j is called good if nums1 of I is divisible by nums2 of j into k. So basically, if some number into k is a factor of some other number in this array, then it will be counted as an answer. So you need to find such pairs, like the number of such pairs that satisfy this condition, that a number in the first array should be divisible by a number in the second array multiplied with k. Right? Like if you multiply with k, all these numbers will remain same, 1, 3, 4. So let's see how many pairs are there. So 1 is divisible by 1 here. This 3 is divisible by 3 and 1. So total 3 pairs we have encountered till now, satisfying that condition. And for this 4, we have another 1 and this 4. Right, so in total, 5 total pairs are there. If we sum up, then the first pair will be 1, 1, and further pairs will be 3, 1, and 3, 3, and again 4, 1, and 4, 4. Right, I hope it makes sense. It is clear to you. Right, so similarly, you need to find like how many pairs. So since k is 1, so this must remains same. This array. So if we take this example, so this is 2, 4, and k is 3. So what's the intuition here? So the nums2 will become so nums2 will become 6 and 12. Right. So yeah. And now if we try to find the number of possible pairs that satisfy that condition, we will be getting 12, 6, and again 12, 12, and yeah, so only this number also, since all other numbers 1, 2, and 4 are not divisible by either 6 or 12, so we get these two pairs. Right. So since the constraints are very low for this problem, I have just brute forced it. So I can show you my solution here. So I just iterated through both of those vectors. Initial outer loop is for the first vector, and the inner loop is for the second vector. And if the first number is divisible by the number in the second array, then I understand is the answer and return the answer. So that's the first problem. Let's go for the second one. Second was based on greedy approach, I would say. Yeah. So in this we are given a string, and in that string some lowercase alphabets are given, and we just need to count how many uh, consecutives consecutive similar letters are there, and if they are larger than 9, like the number of consecutive alphabets, if they are greater than 9, then we need to divide it into groups of 9 or smaller, right? Like if you see here, before this B, there are 14 A's, right? So we have divided it into two groups with 9 and 5. So 9 A's and 5 A's, and along with the last two B's, right? So you need to output in the form of this. So what we can do, we can just take a count variable, right? And uh, and another variable with the character, let's say ch, and assign it to some random value which is not present in the string. I am doing so as to compare the previous letter with that with the current letter while iterating the string. So let me show you my solution here. What I have done is like I have taken this string answer, and I have taken two while loops. I have defined I here, and I have taken the current as of I, and since count is zero, initially we have taken count as zero, and while I less than n and s of I equals to character, since we have assigned current to s of I, so for the very first variable, s of I is gonna be equal to current, right? So s of I will be current and count will be increased and also I will be increased, and it will be performed until count is less than or equals to 9. As soon as it goes beyond 9, we will again start our count from 0, right? And this is inbuilt function in C++ that converts any integer to string. So I have appended that count as a string into the answer and added current. Right, current is the character that is occurring count number of times. So yeah, that's it. So this will give you the desired result. So I hope this is clear now. Let's go for the third one. Third one was quite a bit interesting. It was just another version of the first problem, but I would say it was a medium level problem because the constraints were a bit the constraints were a bit more difficult to solve compared to the first one, but the theories which are going to be used to solve this one was not that much because as you can see in the constraints, it's only up to 10 power 5, so it can be still manageable in n square root n, right? So I have used that n square root n. So what this basically says is you need to find some pairs I comma j. The similar statement is there for that was for the first problem. So if nums one of I is divisible by nums two of j into k, you need to find such I and j pairs. Right. So similar examples are given. So in this problem, you can't just brute force because it will be of n square, then it will go up to 10 power 10. And in C++, only 10 power 8 operations, or I think 3 into 10 power 8 or 2 into 10 power 8 operations are allowed in 1 second. Right. So n square is definitely not possible. So since n square root n solution was valid, and how I went for that, like what I did was to store all the prime factors, all the factors of all these numbers, right? All the numbers present in nums one. So take out factors of all the integers present in the first array, first vector, and store them inside a map. Or you can use any other data structure, but I have used map here. It is easier to use. That's You can also use a vector here because the constants are only up to 10 power 5, or sorry, the numbers are up to 10 power 6. So you can use vectors also, but I have used a map. So you can store them inside a map with their frequencies, along with their frequencies. So now the question arises, like how to find all the uh, how to find all the what is factors, how to find all the factors. This is the question now. So we have used the method that we use while doing prime factorization. I don't know the exact spelling of it, but I hope it is Z-A-T-O-U. Okay. So we have tried to prime factorize each and every number and store them. So how we do that? That prime factorization. We go from let's say the number is num, right? So what we do here, we go from I equals to 2 till uh, 2 till the number, let's say n, where n square is still less than equals to none, and n plus 1 square, n plus 1 square will be greater than none, n plus 1 square is greater than none. So revisit from 2 till n square, because all the factors of a number are within can be calculated while traversing from 2 till n square, 2 till the square root of that number. Right, so if I show you my solution, in the solution of this one, so I have defined an answer variable and two integers n1 and n2 which denote the sizes of the vectors, and we have an unordered map just to reduce the complexity, because map stores the key value paired in the sorted order with sorted keys. So we have used an unordered map, or else you can also use a vector. So we have just traversed through the first array and took all those factors of it and stored them in the array, right? So I have visited from 2 till the square root of that number, since the j square is less than equals to number. And if that number is divisible by that factor, then just increase the count of that factor, right? And one more thing, like if you see this example, so in 12, when it will be divided by 2, right? So why this step is being called is because, let's say we are considering, okay, I can't relate it. I will tell you later on. Just now let me explain this code. So this is just like, let's say if you are considering 12 and j equals to 2, then the x will be 6, right? So that should also be counted because 6 is also a factor of 12. So since 2 is a factor and 12 is divisible by 2, so 12 by 2, that is 6, must also divide 12, right? So 12 is also a multiple of 6. So that's why we are considering 6 as well as 2. So 2 will be counted here and 6 will be counted here, right? And apart from that, so when you prime factorize 12, you will get up to 3, right? Because 12 will be first divided by 2, it will become 6, and then again divided by 2, it will become 3. So now your j is 3, and j square will be 9, and your num has become 3. So this condition will be false, and you will be breaking out from this loop, and you will come here, right? So why this map of num plus plus is because, let's say you are got to 1, right? And in And in this case, as you can see, the nums2 vector also contains 1. So we need to count that also, right? So whatever the last number we have got after factorizing it, so we will increase the count of it, and also like the last number, if it is greater than 1, like the case I have told you for 12, so it is 3, right? So if it is not 1, if it is greater than 1, then only we will, then what we do, then we will increase the count of 1 also, right? Because